Hello, this is Minky for the course Probability and Stochastic Process. This is homework 6, exercise 1. The first question is let us to find the A so that this function is a valid joint density function. So for the first question, we could just solve this. It is double integral from the minus infinity to infinity and minus to positive here, and the joint density function dx dy equals to 1. This is the characteristic of the joint density function, right? So if it could be 1, then we could solve A is equal to a specific value. So we can use this to solve this problem here, and x is the absolute value of x is smaller than 1, and y is smaller than 1 as well. So x is between -1 and 1, and y is between -1 and 1. So that's why we could write this. The lower bound is -1, and the upper bound for x and y are also 1. And between this, the value of this function is 1 plus x times y over a. So we could just solve this integral to find a, and a is equals to 4. For the second question, we are gonna prove if x, y is uncorrelated or not. So if we wanna prove two random variable is uncorrelated or not, we could just to calculate the expected value of x, y, and the expected value of x and expected value of y. If they are, we could write equal here. If it is equal, then they are uncorrelated. Yes, they are uncorrelated. So if it is, we could not write equal here, and they are not uncorrelated. Yeah, that's right. So firstly, we are going to find the expected value of x times y. And so how to solve this? Also the double integral here, and we use xy times the density function and dx dy. This is the definition of the expected value. So by solving this here, you could see that it equals to 1 over 9. And then we need to calculate the expected value of x and the expected value of y. Here you could see that I firstly find the marginal density function of x. That is, based on the definition, we use fxy dy, that is the density function of x. So if we want to solve the density function of y, there should be dx here. So firstly, we solve this and use the definition of expected value. That is x times its density function to solve that. This is the first way to calculate the expected value of x. The second way is that we just directly use the joint density function, that is to use x. Yeah, it is x times fx fxy xy, that is joint density function here. Dx dy, x is between, and here we could just write the lower bound and upper bound of xy here. So by solving this, we could also get the expected value of x. Yes. So after calculating this, we could get the expected value of x is equals to 0. But here we previously we get the expected value of x times y is equals to 1/9. So this can't be right. We could not write equal sign here since this is 0, this is 1/9, so they could never be equivalent. So x and y are not uncorrelated. I think there should be are not uncorrelated here, right? So since if it is a equal sign here, they are uncorrelated. I made a mistake here. So this is x and y should not be uncorrelated. For the next question, if x and y are independent, previously I just find the density function of x and y. That is the marginal density function here, right? So by times these two marginal density function, we check if it is equals to the joint density function. If they are equal, they are independent. But they are not equal. So y and x are not independent. And for the next question, we are going to find the joint density function of x with the power of 2 and y with the power of 2. So we can define two new variable here. That is, z is equals to x with the power of 2, w is equals to y with the power of 2 here, and using the fundamental theory for the two random variable here. Firstly, we are going to calculate the Jacob matrix. That is you could just hit here. Firstly, take derivative to x and take derivative to y, and omega and w take derivative to x and take derivative to y. So then we could calculate this determinant is equals to 4 times x times y, and the fundamental theory is that this two new random variables joint function is equals to the original joint density function over the Jacob matrix. Here should be determinant here and take the absolute value based on the how many roots we got here. So we should, if there is only one root, we could just write 1, and if there's 2, we need to plus another root here. Yeah, like this. And based on this question, z is equals to x with the power of 2, and w is equals to y with the power of 2 here. So we have 4 roots, right? X equals to positive or negative, z take the square root, and y is like this as well. So we just take it back to this fundamental theory formula. We could solve the W's joint density function is like this, right? And we should also write that x and y has a limit here, right? X is like this, otherwise they are equals to 0, so we need to write z and w's limit here. Yeah, I think that's it. And for the last question, we're going to prove if z and w are independent. So we just calculate if these two marginal density function is equals to the joint. Sorry, this should be right. This should be ZW, the joint density function. If they are equal, they are independent. So, yeah, based on the marginal density function, we could calculate these two marginal density function, and we just time them together to check if we could write a equal sign here. So based on the calculation, Z and W are independent. Yeah, I think that's enough for this question. Thank you.